Who knows what biomimicry is? Raise your hand. Excellent. Excellent. Well, then this is going to be a very boring presentation for you. If you don't know what it is, biomimicry is really synopsized by what Janine Benyus, who wrote the book Biomimicry, wrote back in 1997, which is that natural organisms have figured out how to do everything we want to do, except they do it without guzzling fossil fuels, polluting the planet, or mortgaging our future. Is that true? That is true. I'd like to start with this example of baby formula, because it's completely a good indication of how humans have one conception of how things work, and nature has a very different conception. So some of us may have been raised on baby formula. It's a pretty fascinating process. So mankind first decided, baby formula, what do babies need? They probably just need like some cow's milk and some malt flour. They'll probably survive. It wasn't until 1935, they're like, let's add some protein, just in case. Iron doesn't show up until 1960 almost, and we don't even get to like essential fatty acids until 2000 for brain development. It's a really good indication that we have no idea what we're doing. It's amazing that humans have survived off of baby formula. That's another like big lesson learned. But nature knows how to do things really well. And the reason why it knows how to do things really well is because it's had millions, if not billions of years to evolve. And it evolves for very specific adaptation circumstances. So does anyone know what kind of bird that is on the left? Yeah? Very good. Kingfisher? Why is a kingfisher so good at entering from one medium to another? What's its chief? That's right. How freaking long is that beak? So in Japan, there's the Shinkansen bullet train, and it goes about 300 miles an hour. And every time it was going through the tunnel, it would cause a boom. And it's because a pressure wave would develop in front of the train, and therefore it would cause this loud boom. Eventually, the people of the town are like, can you stop the loud boom every time it goes through the tunnel? So it turns out that the engineer for the train for JR West was a birder. He's like, what goes from one medium to another without making a splash? Kingfisher. And the reason why the kingfisher does that is because if it didn't evolve and adapt to doing that, it would not catch the fish, right? So it had to work. By following the geometry and changing the front of the train from being like literally shaped like a bullet to being shaped more the same geometry of the kingfisher, 20% greater efficiency, no boom, and it actually went 15% faster just by changing the geometry of the nose of the train. So biomimicry is also, it's a radical vision for how to design, manufacture, and run our world. It really sits at what Claudia was saying. It sits at the intersection between going outside and what do we want to make? What do we want to do here as humans to make stuff that we actually use every day? This is a great company called Sharklet. So have you ever seen a shark? They don't actually get barnacles attached to them. Why is that? It's because they have these dermal denticles, and that's what it looks like at the microscopy level. Those denticles prevent bacteria from adhering. So a company said, what if I just follow that pattern alone? They were able to eliminate 85% of bacterial adhesion just because it followed the pattern of a shark. So now that application is being used in hospitals where superbugs are killing thousands of people every year. Millions of people get infection every year in hospitals. But just by putting this on the surface, they're able to change that equation. So termite mounds can regulate their entire termites in big fluctuations from cold nights to hot days. They don't use any fossil fuels to do it. It's all based upon the construction of these, it almost looks like bronchial tubes, series of if you've ever seen the inside of a termite mound, it's fascinating. We use 20% of the world's fossil fuels to keep our buildings regulated. What can we learn from a termite mound? Every year, nature doesn't send any wastewater, right? Whereas in India, every year, just in the textile industry alone, we're sending 425 million gallons of polluted water back into the stream. That Scarab Beetle, which is a stunning thing creating with lots of color, doesn't use any pigments or dyes or heavy metals to make its color. We're using about 750,000 metric tons a year just to make our stuff. And where's that water going? We talked about, Chris was just mentioning drought. When we have drought, do you think that that's going to be a worthwhile use of water? I love this example because, so that's a real thing, right? Has anyone seen a scarab beetle like that? The rainbow scarab? They're beautiful, right? They look like they're jeweled, colored. It uses one material, chitin, and it changes how that one material, chitin, is structured to get a different function. So it stacks in a certain way to refract certain light to get the blues and the pinks and the yellows and the greens. And then it creates different porosity with that same chitin to have a breathable shell. It cross-hatches it in order to get a hard shell. It has different joint mobility. It's all one material. It's all just chitin. But nature uses structure to create different functions, whereas we think about that potato chip bag on the right, that's 7 different materials. There's a pigment layer, there's an oil layer, there's a keep your air out layer, there's a coating for the branding. Which one's easier to recycle? So I love this quote because this mechanical engineer said, you have to ask yourself, is our structure best? He points to other natural structures like trees and spider webs that are also strong and lightweight. When you learn something, you realize how little you know. So I'm just going to flip through these really quickly. These are examples. These are all on our website at Biomimicry. You can learn more. OptiStruct makes lightweight planes and cars based upon how your bones stack. So your bones have a series of crystals in them, and when you start to move a certain way, your bone throws more material behind that place where there's stress. OptiStruct uses that same algorithm, Chris was just talking about natural algorithms, uses that same algorithm to lightweight by 40% sometimes a given structure. That example in the upper right is a really good indication, before and after. It's all just following one algorithm. That's how bones work. The idea of spirals, there we go, is really powerful. This is a product by Pack Scientific. It can move 7 million gallons in an hour based on 300 watts of power, because that's how powerful the function of spirals are. And we see spirals all the time. You see them in your pores. You see them in how branching pattern of trees work. It's a very efficient pattern that nature does over and over and over again at the micro scale and the macro scale. This guy figured out how he can have industrial applications that are fascinating. You don't use as much chlorine in your water when you circulate it all the time. It has huge benefits for just knowing how to do this with the least amount of energy. I love this example, Ornilux, because that spider web, mama spider invests a lot of energy in putting together a web, does not want a bird to fly into it. Quick question, how many birds die a year by hitting a window? Guess. Give me a number. Give me a number. 300,000? Way more. 3 million? Way more. 50 million? Way more. Somewhere, what, Chris? Yeah, somewhere between 365 million and 1 billion birds die every year just from hitting the window. And they're not even at high rises, they're like this level window where there's a tree outside, they get confused by the reflection, and they run into it. This company, Ornilux, was really horrified by that number, and so they put in the same ultraviolet little threads that a spider does into its web, because, again, the bird's not flying into the web because it sees ultraviolet light. We don't see ultraviolet light, so we can put these threads right into a window. It looks perfectly clear to you and me, but the bird sees it, and it does not run into it. It's a really beautiful and effective application. This is an example of what, if you look at the microscopic level of the Morpho Butterfly, so it's amazing, right? It goes from looking like shingles all the way to looking like almost like zippers or railroad tracks. That's constructive interference. It is canceling out every other color of the spectrum except for that bright blue. So it doesn't need pigment. It's just using light. That same pattern also means that it can bust up water droplets and therefore making it hydrophobic at the same time. It's structure. Nature uses structure to create different functions. So that's what biomimicry is. You guys need to enter. We have a design challenge every year. It's a really good application of what Claudia was talking about. How do you get physically involved in doing something? It's a way to learn on the job while solving a huge problem like climate-related problems, food-related problems, transportation-related problems. These are teams every year. These are just some of the designs that the teams have produced. This models a snail shell because the deepest part of a snail shell is where it's coolest. This one's called insolation. I like saying it, so I always include this slide. Mimics how, how a pine tree will collect snow, and that will actually act as a radiant barrier. So this is a place where they get a lot of snow every year. They also don't get very much light. The snow reflects the light back into the building. It also acts as a natural insulator at the same time. This is a way in Mexico to collect water, ambient water, from the difference between being hot during the day and cold at night. That condenses just like the bromeliad leaf, which is like the top of a pineapple. It collects down to a central channel. It can sink liters every day. And this guy out in Italy created the same structure. It's 30 feet tall. It can sink 25 gallons a day. Anyway, please go to our website and check this out. Last thing I want to say is that we have this, it's called asknature.org. Type in your functional question. How does nature filter? How does nature adhere? You'll see a list of organisms. Thanks very much.